Yeah. So, hi everyone. Uh, let's share my
I think
screen.
the
You can
poll
end
has
the
to
poll.
end, otherwise we're able to see the.
Yeah. Thank you.
Pratik sir, you can continue.
Yeah. So, is the screen visible?
Yes, yes, yes.
Okay. So, we'll continue with Matplotlib. I'll zip past through it somewhat quickly so that Jigar can focus on his stuff. So, the notebook I'll share will have more examples and more formatting options. Right now, I will not focus on how to make your images look pretty, like use all the formatting options of the plot. We'll just see how to plot basic stuff and only the important things. So matplotlib is a plotting library in Python, and matplotlib.pyplot is a collection of functions which behave like MATLAB does. So to import it, we'll just use import matplotlib.pyplot as PLT. So throughout our code, we can use PLT dot whatever the functions are inside this module. And we'll also import NumPy because we'll use that. Okay, so let's create a range of objects 0 to 10, and let's just plot e to the power x, exponential of x. The way we plot is we can just use plt.plot. So plt, that is matplotlib.pyplot, has a function called plot, which accepts x and y axis. So this will be our x-axis, then our y-axis. X will take the values from 0 to 10, y will be the corresponding exponentials. Just this simple code will give us something like this. Okay. Now, what all things we can add to it? So there is something called as markers. If we want the data points to be shown, we can use different markers. Like O will give us this dot. Now, what all markers you can use, I have listed it, all these different kinds of markers we can use. So if we have multiple plots in the same plot, uh, if we use plt dot x label is a function which we use to name the x and y axis. X label similarly as y label can use e to the power x. Okay, so this x will appear on the x-axis, e to the power x on the y-axis. Now, for people who are familiar with how LaTeX works, LaTeX is a TypeScript language. It is used to write research papers and equations in functions and everything. So Matplotlib also accepts LaTeX, so we can just write enclose equations in dollar dollar, and it will format it in a nice way. So it will write it as the equation y equals to e to the power x. So regarding this, how we can do, I have put it in the main notebook that I'll share after this class. So this is a basic function of my plot function. So plot x and y axis, whatever markers, marker size, and everything, all the prettifying things I have listed here, how to do that. How we can have solid line, dotted line, dashed line, and how the FMT syntax is and all that. Then we also have some important things is like plt.title, like you can write exponential. So title will give us the title of the plot. Then we can have grid lines, plt.grid. We'll just put grid lines. If we want major grid, minor grid, you can go through the matplotlib documentation and see how we can put minor grids if we want. And so on, we can go on, keep adding whatever stuff we want to in matplotlib. Now let's just see how to use it a bit more with NumPy as such. Also in astronomy, we need to use log scale quite a lot. So, okay, I'll just demonstrate that quickly. Suppose it's to the 20. Um, so instead of using another axis, I can just plot a comma a, and let's say I'm giving it the color red. This is just a straight line because I'm just plotting a on the x-axis, a on the y-axis. But if I again do PLT dot plot a comma a square, and I'm giving it, let's say, blue color, this is the square plot. This is a square. Now you see, if I keep on adding PLT dot plot, PLT dot plot, it will be plotted in the same figure. But after this, if I put PLT dot show and then again PLT dot show, then I'll get two different figures. So basically, in Python, each line is executed at a time. So after this line, I'm saying show me this plot. After this line, I'm saying show me this plot. So that's why two plots are plotted. This similar thing can also be done by defining PLT dot figure before the plot. It will give the same results. So the reason that we can get away with not writing them in the first place because by default it assumes that you have put plt.figure or plt.show in Jupyter notebooks. But if you're writing a bare bone .py file, Python script, then you will have to put plt.show if you want it to be displayed when you run the code. Okay, so I'll plot one more line in the same plot of a cube, higher power, and let's say give me yellow color. Okay, so a square, and a cube. Now I can have label here. So in the plot function, there are many keyword arguments. There is a list of keyword arguments that I have mentioned in the notebook. So the most important ones that you'll need are the x and y axis, what is the color, what is the shape of the marker, and what is the label. Label will determine what will appear in the legend if we ever want to put a legend in the plot. So if we say label equals to, this is equal, basically x equals to y. Then here we have, in fact, I should have y equals to x.
You may just write linear, quadratic, cubic.
Yeah, that also I can do. Yeah. Linear, quadratic, and cube. But it won't do anything if I don't write that I want to put legends. So for that, we have to put plt.legend. So this will put this box here. It will show us what this line indicates. Yellow is cubic, blue is quadratic, red is linear. Now in astronomy, we use log scales a lot because the distances are huge and you want things to be in the powers of 10. So in Python, there are multiple ways that you can use np.log here, like before this, or matplotlib itself has log. If you want both x and y in log scale, you can put log here. Copy this instead of typing again. So this will give me all both of the scales in log. So these are log scales. That's why it's showing as straight lines, but above each other. So this is one of the thing. And if we want to save this figure, then we use plt.savefig. Savefig, and in the string you can type the file name. Now I'm not going to save it, but you can type the file name and that this figure will be saved in your current working directory. Current working directory in the sense Wherever you have stored your Jupyter notebook, there this image will be saved. If you want it to be saved in a specific location, just give it the full path wherever you want to save the image, like C, Drive, Documents, whatever folder, everything you have to put inside the string in the save file. Okay, so then there is also limits that we can put. So I'll show you in this also only. So plt.xlim and plt.ylim. So xlim and ylim takes limits on x and y axis. So say what is the x-axis here is 0 to 17. Suppose I want only specific part like 4 to 10. And in y limit, I want just 4 to 10 is nothing actually. I'll take 12 to 15. On x-axis and y-axis if I want just up to 2000. So we put limits like this. So quadratic is going out of frame here, but yeah, we can limit what part of plot we want to see by putting x and y limits. What else? So I'll just zip pass through this. You can read this when I share the notebook with you. Okay. So now let's just use one of the random functions that we had. Like suppose we have values of theta and p dot random dot random normal distribution. We have 1000 theta values, and we can just plot them in p dot sine into pi t and p dot pi into t. And I want to plot a scatter plot. So here we use plt dot plot. Plt dot plot will give us a line plot. Plt dot scatter will give us a scatter plot, which is dots. Plt dot bar will give us a bar plot. So plt dot scatter t comma y. Let's just see how this looks. Okay. So why is the plot like this? Basically, it's a normal distribution. So most of the points are concentrated around 0. And as we go away from 0, the points will be spaced. Now, it is not clear that there are many points here because the thickness of the point is too much. So to reduce the thickness, we can just say s equals to 1. S stands for size. We can change the color to say blue. It's already blue, red, and we can put a label. We can put a label that this is a sine curve. So it will put a label like this. Now what we can do is building upon that. Suppose we have random dot random integer. So we take a lot of more points, 5000 points from the normal distribution. Then we have y1. We have sine p dot pi into the x, and we're adding some noise to it. By noise, I mean I'm just adding some value from another random distribution. Again, 5000. So what this will do is for every point, it is calculating sine pi x plus this is just a scaling factors that I will show you what happens if I change this. I'm just adding some random value to the actual sine curve. So it will just go above or below the sine value. P dot sine and p dot pi into x. Sorry, I wrote sine again. So I'm making this two curves, sine and cos, and the same thing from above. And I added some noise to it. Now let's say plt dot figure. You don't need to mention this, but you plt dot scatter x comma y1, plt dot scatter comma y2. Let's just see how this looks. So you see there are two sine curves with normal distribution, so they're concentrated in the center, and there are many points because of the random function that I used. Let's just reduce the size of it so we can see it nicely. Give it color. I'm giving it red color, and this is a sine. Let's say this is a green color, and this is a cosine. Okay, so these are the points. Now in the plt.figure, what we can do is if we want this image to have different resolution, different size, we can put it here. So it uses the keyword fixed size for the size of the figure. Let's say I want it to be 16 by 9. And I want the DPI stands for dots per inch. And I want it high resolution. So I say DPI 200. And what else can I add? Legends. We'll put legends here. Let's put title. It's legend. So this we get a big image, like it's a high resolution image. Now, what we can do is you can create something like this data, just a random data, and you can use this to practice curve fitting. You can try to fit a quadratic curve to this and see if it looks like a sine. You can create some such random data to test out your functions on it. So this is a useful thing that you know how to do this using NumPy. Now I used your random normal distribution. You can use any kind of distribution.
And if you
Now,
reduce that 0.25 to lower number, the width should
yeah,
reduce,
the
right?
width. So the spread around the sign will reduce. If I, let's say, if I need 0.01 only for sign. See, for the red is the sine curve. For sine, the spread is reduced, but for cos is more. So this is just a scaling factor. If I use 0.5, for sine, the spread is more. So is till here, is it okay? Does anyone have any questions about all this? I know I'm zipping past quite fast, but if there are any questions, let me know. Okay, so now just one last thing in matplotlib. It's quite simple. You just need to know plt.plot, plt.scatter, all the beautification things you can go through matplotlib documentation because there are so many functions that even I don't know all the functions after using it for so many years. I have provided links here for the entire list of functions of matplotlib. So you can go to tutorials or examples. And from these examples, you can see what the documentation examples have shown. And you can see how they have done it because you can get code for that and you can see. Okay, so one last thing before I hand it over to Jigar is I just wanted to show how we make subplots. So normal plots are okay, but what if we want four plots in one single plot? Then there is something called a subplot. So I'll show how to do that. So let me create some data first. I'm using linspace now, 0 to 4 pi. I'm taking about say 1,000 points between 0 to 4 pi. And let's create sin x and p dot sin x. Let's create sin 2x. That is sin x square cos x and cos square x. Oh, there is no equal. Okay, so we have this data. Now to create subplots, we'll use this figure comma axis equals to plt dot subplots. Okay, so plt dot subplots returns two objects. One is the figure and one is the axis. That's why I've used figure comma axis. So in Python, we can use this. So if I say a comma b equals to 2 comma 1, and if I run a, it will be 2. If I run b, it will be 1. So we can unpack the literals. This is called unpacking. I can give many, define many variables and give it values. Okay, so C will be 3. So I'm doing this figure comma axis because plt.subplots returns two objects. One is the figure and one is the axis. So plt.subplots, the first index in the plt.subplots is the number of rows. So suppose I have two rows and two columns. So 2 comma 2 will give me two rows, two columns. That is four plots. And here itself, I can give figure size. Say I want a big figure now because there are four plots. And let's say DPI 100, not that high resolution. So how to access each of those subplots? Suppose we have four plots like this, 2 comma 2. So the first one will have the indexes of 0 comma 0 because first row, first column. So 0th row and 0th column. 0th row, first column, first row, 0th column, and first row, first column. So that will be used just like list indexing. So 0 comma 0 will give me access to the first subplot. And I can use dot plot x comma sin x. 0 comma 1 dot plot x comma sin 2x. 1 comma 0 dot plot x comma cos x. 1 comma 1 dot plot x comma cos 2. Its axis ax. Okay, so this gives me these four plots. One of sin x, sin square x, cos x, and cos square x. Now for each
That
of
is
those plots,
that is
yeah,
sin
yeah.
x squared. If you
Oh, yeah,
want a
sorry, sin x
sin,
square. Yeah, I said sin square x, right? Yeah, it is sin x square. If I want sin square x, then I'll just write sin x and then raise it to the power. So ax dot plot this, and using the same method, I can add stuff to the subplots like labels and so the syntax changes in subplot. So in normal plot, we just wrote plt dot label, right? X label, Y label. I did it somewhere. X label, Y label. Here we did X label, Y label. But in subplots, we will have to write set X label and Y label. Normal X label won't work. It will throw an error. And we can do all the normal. So this plot in the subplots thing accepts all the keyword arguments that are used in like color, line type, markers, and everything. So X label, Y label. And here we can use dollar. So sin x. I'm just giving proper indexes here for all the three lines. So this gives me access to first plot, first row, second plot, second row, first, and second row, second. Now this will just give it labels like cos x, sin square x, and cos y. And similarly, we can add legends, titles. So ax dot set title will give you title for this plot, but there is something called a super title, or we can use plt dot title. So super title will give one common title for all the plots. So all these things, yeah, I think this should be enough for Matplotlib to get you started, and you can experiment other formatting things with the plots. And yeah, so that's it. If you have any questions, let me know. Else, Jigar can take over from here. He will teach functions, how to write functions, and some simple examples about curve fitting using SciPy.
Can we just see the graphs?
Yeah, sorry.
Okay, means the okay. This should be cos x.
Oh, sorry. Yeah. Okay. So I did not write properly. This should be here. This is cos x, and this is cos. This is correct, I think. Yeah. Yeah.
Any questions for Pratik?
There is one hand raised, I think.
Rajeshwar, you can unmute and ask.
Sir, I have doubt in the definition of the syntax of subplots, sir.
Okay. Go ahead.
So what's that 2 comma 2 means here, sir?
So this is basically you are giving shapes. So 2 comma 2 means two rows and two columns. So this is two rows and two columns of subplots that I have. So if I put here 1 comma 2, it will just give me one row with two columns. So I'll have to remove this part. Oh, I had to also change this. So this 1 comma 2 will just give me two subplots, one here and one here. Instead of 1 comma 2, if I put 2 comma 1, it will give me one below the other. So just two rows and one column. So I'll get two rows and just one column of plots.
Yes, sir. I understand. Then what about that figure size, sir?
Figure size is just, so if you don't write that, that's also fine. So by default, it will be some figure size, like it will be small. So it gives a square, but if I want some specific size, so it's basically aspect ratio, or so I use 16 by 9 because 16 by 9 is the aspect ratio that most screens have. We can also use something like 20 comma pi. So 20 is the length, pi is the breadth. Oops. So 20 is the length of the whole plot and 5 is the breadth. So this will give me a bar of plot.
Okay, sir. My doubt is clear. Thank you, sir.
Yeah, no problem. Any other doubt?
Yeah, one more hand raised. Please unmute and ask.
Sir, how can we plot the 3D plot?
How can we plot
3D plots in Python.
3D plots?
Yes, sir.
I haven't covered that today, but to plot 3D plots, you would need three axes here, and in subplots, there is something called as projection equals to 3D you can write. So I can show that to you. I have some other notebook I can show you to you from that if you want. Is this visible?
Yes.
So here I had just tried. So there is this Lorentz attractor. Such kind of figures. This is the cover page of Griffith. If you remember, it's just in red. Electrodynamics book. So Lorentz attractor uses these equations dx dy dt. You can do all these kind of things that you can have dark background, you can have fixed size, constrained layout, you can remove the spine of the x and y axis and all these things. And to plot it in 3D, you can do the similar, the code will be same, but in just plt.figure, you can add this add subplot projection equals to 3D. So this will create a 3D plot out of it. And to change the your perspective from where you are watching, you can, there is this setting panes, and you can set up your own coordinates from which angle do you want to watch it. So I can send a link for the documentation if you want to check projection equals to 3D. Then there is also a good library called Plotly. So Plotly also gives you access to interactive 3D plots. So you can drag and move around that. There's the docs. Okay, I'll attach all these links in the, if you're interested in this, I'll attach these links in the notebook that I'll share. You can explore that on your own pace. Right now, I think Jigar needs to take over as he has stuff to cover.
Sir, I had a small doubt.
Yeah.
Sir, you mentioned plotline, right? So using that, can we implement VR interface also?
Sorry, can you repeat?
Like, if we can implement the 3D interface, can we plot like stars in virtual reality setup also in that?
I'm not sure. And I've never heard about that. No. I think for VR, we would need some rendering software, not directly from Python. I'm not aware of any such thing.
Okay. Anyway,
But
thank you.
yeah, you
Pratik.
can have 3D plots where you can have stars and everything and you can move around, but not VR. So yeah. Thank you.
Thank you, Pratik. And you can post your questions in the chat box, and Pratik will try to answer it.
Yeah.
Okay. So thank you, Pratik, again. I think I'll ask Jigar to take over.
Yeah.
Hi everyone, how's it going? As you know myself, Jigar already. Shekhar sir has already introduced myself and Pratik, so I'll just be going along with what I have to teach, which would be functions and curve fitting using sci-fi. So any of the questions, I mean, So functions would be one of the major topics in Python or while learning Python. So I want you to be um, like I don't want you to hide any doubts and just go along with the chats or just unmute yourself or raise your hands. And me and Pratik would try our best to figure out how to solve your queries. So with that on the say, we can start with I'll start by sharing my screen. So let me just okay. Yeah, are you guys able to see this one?
Yeah.
Yeah. Right, so we'll start off with functions first. This would be, so what is exactly a function? It's just kind of a reusable block of code which you want to use it again and again, and like just to perform a specific task or something like that. So functions are basically used to manage your code, reuse your code without, writing it again, and also making your code more readable and modular, if you can say. Uh, it's just a good practice to use functions here and there if you feel like, your code is being reused again and again. So functions, I'll just write off the heading here. Functions, and how do you define a function? So define a function. So it goes with DEF. DEF stands for define. Define the function name. So say name. That would be the function name. And inside the round brackets, you're gonna what you're gonna do is put the parameters of whatever. Like for now, this is just gonna be parameters, and then I'm gonna put a comment here, say code block, right? So this is then going to return something. So something can be, I'm just gonna define something as none. So it'll do some calculation here, and it's gonna, assign some result, something like that, and it's gonna return that result again. So use cases of a function would be, say, for example, um, say, y is equal to x square. So that's one function which, people are aware of. So how do you kind of do this in Python? So you make a function called y, and the parameter is just one. So it's going to be x and then colon. That's how the syntax of a function works. And then you press enter. It's automatically going to indent the next line. And then it's going to return whatever you put in the function as, so x, and then return x squared. So that's your, like, the most basic level kind of function. So when you run this cell and you come up to the next cell, what you do is, if I just say y is a function and it's defined in this particular Python file called main. So we'll not get into that right now, but this is how, if you don't call a function, this is how it's going to be. But now if you call a function, by calling a function, I mean put round brackets after the function name. And then as I defined it, it only takes one variable, which is x. So x equals, I'm going to do it as 3. So this is going to return 3 squared. So that's going to be 9. So that's what I expect, right? Now, if you have the more, the official kind of, what do you say, more well-known way to define a function would be, I'm going to write the same function. And here, there's this thing called docstring. And docstring represents what the function actually does. So say, for example, I want to use this function later down the line. So I have so many, I have written a lot of code here and I forget what the function does. So I don't want to look back and go to each of the logic, like the logic I've written inside the function. I can just call the docstring. So this docstring would be optional, but it's used to describe what the function does. Right? So in this case, this function would returns x to the power of 2. That's all I need to know. And maybe arguments. Arguments are just what you put in the function, which is x. So x would be one of the arguments. So x is a number that you want to square up, right? That's going to be your docstring. So once you are done with the docstring, put the logic in. If at all somewhere down the line you want to check the logic again, like say check the function you have written again, it's useful to add comments on each line of the code, I guess, because when you are doing complex queries or calculations inside the function, you should know each line does what exactly without reading the logic. So in those cases, comments are very useful. So in this case, I can just say the line, I'm just trying to understand what this line does. So it's going to return the value of x squared, right? So this, I'm defining the function again. And when I call this function without putting in x, if I hold shift and tab, I get a pop-up which says docstring. So this is exactly what I wrote in my docstring there, right? So if I want to call the function, maybe say like a few hundred lines or some other Python file, I can just simply use this handy shortcut to locate, like to actually see what the function is about and then figure out why do I need to use it. So in this case, it's just going to be say 4 again, it's going to work the same because ultimately that's what it's going to return, right? So yeah, so ultimately this should be, you can also define local variables. So result equals x the power square and then return result, right? So it's going to give you the same answer here, 16. But now if I say result, it should give me a name error because result is not defined. Whatever variables are defined inside the function stays inside the function. So these variables are so-called local variables. And the variables which are say defined outside are called global variables. So this one, I can ask it to print global variable and also return the result. And since the global variable is defined outside the function, it is also valid inside the function. That's why it's called global. So here, obviously result will give you an error, but this would also print 10 and then return 16, right? And yeah. So when you call a function, whatever whatever variable you have set it to print, or you are in the process of debugging or anything like that, if you print, it will always print when you call the function. And if you return, as I said, like underscore, I have set it as a dummy variable, and I have used that variable and assigned it to whatever this function returns, which is result. And result is just x square. Is everyone following me through this point? Are there any
Instead of
questions?
underscore, it could be any other variable like z or anything, right?
Absolutely, yeah. So z, and then I say z again, yeah. But since we're using Jupyter Notebook, it retains the initial value as well, like underscore was assigned as this, unless it was changed otherwise. So if I run this again, underscore is saved as 16. But yeah.
Okay,
Are there any questions?
is it possible to nullify particular variable? Because when you define a variable, it is going to take some memory. So
I think del underscore does that. So when I say, yeah, so delete underscore deletes that variable from the memory.
thank you.
Okay. Any other questions as of now? I'll just proceed with a few more examples so it'll be clear, because ultimately functions would be used throughout this course and also further down your coding journey. So few of the examples which I would say, for instance, we have greet. So greet and then name. So greet is a function and one of the parameter is name. I put colon and I go to the next line. And I use the docstring, say so docstring is just basically what this function does. So it greets the user by their name, right? And it returns a formatted string. So hello, and then user, sorry, it's name, yeah. So it's gonna say this with an exclamation mark. Once I call this function, I want to greet say Pratik. I want to capital P. So I say hello Pratik. That's one of the rudimentary example of how you can use formatted string inside a function. Obviously there is more to it, but this can also be done with I think this can also be done with numbers. So I want to make a function where I want to add numbers, so a and b. Now there are two parameters, a and b. Both of them say, it's a good practice to add docstrings all the time, because sometimes you make so many functions, you get confused, like what does this do? And it's just a mess after writing all this code and you don't know what your code does. So it's always a good practice to write a documentation string so that you yourself know what you have done. So this is just this adds a and b, right? So I'm going to return, our result is A plus B, and return result, right? So that's one of the example like functions where you can use numbers. So I want to add, say, add numbers, sorry. So add numbers.
There is a request if you can reduce the size.
Reduce the
I mean,
size.
I don't know. So that probably other earlier instructions people can see.
Oh, okay. Probably, I think is this okay?
I think participants can zoom their own Zoom window however they want. So because some people
Oh,
might
okay.
not be able to see the small text size. So yeah.
Oh, makes sense. Yeah. All right.
No,
So
it is
I'll
the
just
other
carry
way.
on.
No, I mean, if you they can zoom in, but zooming out is not possible. That is decided by Pratik.
Yeah.
Okay. So I'll carry on with this size if that's okay. And yeah, so once you have defined this function, you just add the number. So A, you press A and then tab. So that's going to give you what variables you should input. So A equals say 4, and I want B equals 7. So that's going to give me 11. So yeah, I mean, someone raised a hand. Yes.
Sir, can I
Rajeshwaran,
add a condition to this a function like A should not be equal to B, so the input must be two different values. Like can I add a condition to a function, sir?
Absolutely, yeah. So we'll take an instance of if A equal to B, I want to return true. Okay. Check similarity. So else return false. So this is going to give us true if A equals B. This is going to give us false if not. And ultimately, I can remove this, and this is what it's going to do. So check similarity between say 5 and 5. It's going to return true. But if it's 5 and 6, it's going to return false. So conditions can be applied. Those kind of things can be applied as well. So there is really no limit to what you can do with a function. You can, for instance, you can so define a function inside a function. So say outer function x, and the docstring, let's just keep this as an outer function. Oopsie daisy. And that uses an inner function. Right, so that's the docstring of the outer function. Now I can simply define an inner function x, right? And it adds, sorry, inner function, say y, and it's gonna return y square. So y times y. And I want the result to be inner function, and I want x and x. So return result, right? So that's one example of how you can define an inner function. And when I run this and I call this outer function, right? So say, for example, 3. So what is 3 gonna put out as? So it's gonna read this line. So x is 3, inner function, when you input 3 in inner function, it's gonna be 9, right? So this value is gonna be 9, and you're adding 3 again to that 9. So that's gonna be 12. So result is gonna be 12. So when I input 3, it's gonna be 12, right? Now I believe for the use cases of functions inside a function, it's a concept called functional programming, and like it's I have not used it much, but I believe it is efficient to write these kind of logics when your code becomes complex enough. I believe Pratik might be able to answer uh, why use these kind of things in the first place. So yeah, but it just keep in mind that this can also be done. There's literally there's really no limit to what you can achieve inside a function. Um, if you can imagine, you can make it. That's what I think.
Okay, Jigar, we will
Yeah,
take maybe a 2-3 minutes break, and I'll put 2 polls.
right.
So
Okay.
people can answer the polls.
Sir, can I ask a question? Meanwhile,
Yes, sure.
yeah. So my question to is any of you can answer this. Like C++, we have this C out and C out. We have analogously we have print function for C in. Do we have anything in Python where we can take a user input while the program is being executed?
Yeah,
So
we do have inputs, but actually did not show that. But there is something called as input keyword itself.
Yeah.
so like a
So
variable value can be asked by the user while execution of the program.
Yeah, it can.
Okay, so it has input.
Yeah.
yeah.
The
So
poll
it's
is
kind of
put.
like
You
this.
can start answering the poll.
Something like that.
Let them finish the poll, then you can show with some other example, like take a square of that input or something.
Okay.
Just var square, that's
So with
it, in
this
print.
knowledge of how to get a user input and how functions are created, we can make a like a small applet kind of a thing, where we can have options of 1, 2, 3. We can enter two numbers and option A can be addition, option two can be subtraction, two.
Yeah,
Mm.
it can be done. Yeah.
Absolutely. Like if you can even make algorithms to solve Sudoku if that's what you want. I mean, there's really no limit to it.
Thank you.
Yeah.
Okay, let's wait for the poll to get filled. 50% answered. The poll is already there on the screen. It has not yet stopped.
Jigar, print does not
You don't need
pass LaTeX.
to
Oh, okay.
mention that you answered. We are getting all the answers now.
Interesting. So how do I do this then?
I'll have to
Jigar,
check. I
just wait.
think something else.
Jigar and Pratik, just
Okay.
wait, because let people focus on the poll, because otherwise, parallelly they miss out things.
Yeah.
194 people have responded. There are more people in the meeting. Poll is visible to all on their PC. Otherwise, one has to. Poll is visible. Poll is not ended. If you are using mobile phone, probably you may have to check in which window it is there. But that is the reason we have been insisting use PC. No, it is there. The poll is not ended. Now you can see the poll. Okay, I'll end the poll now and display the results, because Jigar can then probably make comments on the questions in the poll. Right now, there is only one poll. See, I now I cannot check whether it is possible on your screen or not, but that is how we are going with it. So I have ended the poll, and I'm going to share the results all. You can comment on every question. Jigar, you may comment on every question.
Right. So the first question is, can we define the functions the way we want in Python? Yeah, absolutely. So, since we have already demonstrated how we can use literally any variable name, it should not be the case that, just give me 1 second here. Yeah, how can I see the poll questions again?
You stop that. No, I'm still sharing it. I have ended the poll, but I'm sharing the result. Okay, I'll read out the.
You can, Jigar sir, you
Okay.
can go to more option and there will be polls. Go
Or
to
there can
more
be
option.
poll quiz at the bottom.
Oh, okay.
Okay,
Go
so
to the more option
the
of
first.
the Zoom.
Okay, got
So
it.
the first.
Thanks.
Yeah, first question is, can we define the function? Second question is, function parameters are put in. So there are three options: parenthesis, square bracket, and curly braces.
Yeah. So it's always going to be like when you call a function, when you want to use that function and you want it to return something, or you expect some output from it, you always call that function. The way you want to call it is use the round brackets, which is what majority of the people have mentioned here. The third question would be function must return some values. Need not be the case. There might be functions which just print. So, so
I think we
you
should
just want,
demonstrate that printing and returning, the difference between that.
Yeah, so go
right?
to the
So,
third and fourth question, and then you can show that. Now, after I stop sharing this result, then you can
Yeah.
show that.
okay. And then the fourth question is return statement is necessary as at the end of the function block. Not really. It really depends on your use case. So if you have any use case where the function is already used in like a block of code and you want a value, yes, return something, go for it. If you just want to, kind of use it to see something or print something, don't return anything.
But return statement will be needed.
No, it won't be needed. No.
No, it won't be. Okay. And last is docking is used for. I think
Yeah,
many of
defining
them.
reading documentation about what a function does. What's the second option? Defining strings used by the function. I'm not sure what that means, but I think the first
No,
option is the
it was
right one.
not the first option is the correct one. Yeah. So I'll stop sharing and now you can demonstrate those things.
Absolutely. So, the difference between return and print would be, say, I have a function. I think I've already defined a function here. I'll just scroll through it up. Yeah. So I've defined this function y, and it takes a input variable x. Now it's gonna print. Let's. You know what? Let's just skip and make a new one. So, say f is a function again, and a is at the input parameter. Now, what is this gonna do? So it's gonna print out a, right? And I'm gonna define it as it is. And if I call, say, f with 4, it's just gonna print 4, right? And if I set a variable, say z equals f4, it's still gonna work out, but z is gonna be none. If I print z, it's gonna be none because the function does not return anything. And by default, if a function does not return anything, it means it returns none. So none in the sense this. So the function by default will return this if there is no return statement given. But this will, since I have called this function, it'll always print a, which is what it does here. But now if I want to return a, this is what I do. So I define a function, like it's the same function, and now it's gonna return a. So z will take the value of a now, and this is gonna return false. And then when I print z, it's gonna be 4. So that's probably the only difference between return and print, as far as I know. But yeah, I mean that's probably the difference. That's probably the main difference I can think of. So we can also do logic, as I said before, in a function. So if I want to say, for example, calculate the calculate just a generic, function where it given a radius, it calculates the circumference and the area. So
There are two raised hands. Oh,
yeah, go on. Siddharth or Panchal.
People are not able to unmute.
Okay. Can you hear me?
Yeah.
Yeah. So I wanted to ask that in the earlier function you defined this inner function, right? So
Mm-hmm.
can we use that inner function again outside the function? Like I just call inner function and will it work?
Absolutely not. So this, whatever functions we have defined inside a function or any variable which we have defined inside the function will only be valid inside this function, main function.
Okay. Fine. Thank you.
No problem. Anything else?
Hello, sir. So,
Hi, how's it going?
yeah, it's going good. My question is that for the third question in the poll, the question was that if we don't give any return statement, would there nothing be returned? It was something like that. I'll read out the question 1 second. I don't know where to become, please.
Question was, is it
Um,
necessary to give return at the end of the
yeah,
function?
no, that was the fourth question. Third question was function must return some value. Yes or no? So
Uh,
you said, yeah,
yeah, it really depends on your use case. So do you want that function to return? Like if,
no. My question is different. So you said it need not necessarily return something. So my question is, let's say I define a function func, which just prints hello, nothing else.
mm,
So if I assign a equals func of, and I decide to print a, it will print none, which is a literal. So
Yeah,
doesn't
so
it,
none is
in fact,
actually an object, so it does return something. You're correct
yeah,
about that.
it returns things.
Yeah.
right. None
Okay, that
is,
was my
yeah,
question. Thank you.
none type. Yeah, it does return none type. So yeah, any other questions so far? Okay, I'll just proceed with the
I have a
example.
question.
Yeah, go on.
What if when we're defining a function, we do not provide any variable inside the bracket parenthesis, and in the lines of code, we are asking uh, anyone who's reading the code or the in the output to input a
Mm,
variable. Will it be
mm.
a disadvantage or will it be just fine?
So in this case, there's no variable, right?
Yeah.
So when you make a doc string and say uh, definition of the function and args, put none, so people can understand that there is no. And even if say I just do return 1 plus 1, this function, if I call it here and I press shift tab, definition of the this thing. So signature is none. When it's automatically going to tell you that there's no variable attached, like in the sense there's no input here, if you know what I mean. Does that clear your doubt?
No,
I think
actually,
there is a
that
question
was
that
not
within
my
the
doubt.
function whether you can ask for a number.
I
Yeah,
think
So whether you
input.
can
we can
input
ask for an
inside the
input.
function.
We can ask for an input. I've tried that one, but my question is that if we do not give any arguments, I mean, if we do not provide any arguments like inside the parentheses any x or y, but we are
Hmm.
taking inputs from the user, will it be a disadvantage if we're using that function in a long code, or will it be just fine?
So
When you want
disadvantage in
to,
the sense, I can answer that because I have used this before. So if you use input inside a function,
Uh-huh.
it will be a disadvantage for you because it will halt your code until you give it an input.
Okay.
So if you don't provide any input, further lines of code will not be executed. So it's a disadvantage for you. It will be easier just to give the inputs in the arguments instead.
Okay, thank you very much.
yeah, so
Uh,
yeah,
yeah,
so we
I
were,
have a question one. This doc string, Is this a
Mm-hmm.
feature of Python or is this a feature of this compiler here, notebook?
It's a feature of Python. So irrespective of which compiler you use, like if you use VS Code, it's going to work there. If you use Atom, it's going to work there, irrespective of anything
Or
you
even
use.
a regular Python, the original Python idle, the basic Python
Yeah,
idle.
you can use that as well. Like even if you want to like type your code in command prompt with good, set of indentations, you can like, yeah, do whatever I have written here, you can do in command prompt as well. So there's this doc string goes everywhere else, not just notebook.
Sir, I have a similar question regarding to the return value of the function.
Yeah.
If I define a variable inside the function and I call the variable which is not defined inside the function is going to return none, sir. So if none is the basic value of the function, so if the function is treated, even if you define any kind of function, even if it's a user-defined function, is it a predetermined value for the function to return none, or it is a zeroth index value of the function to return none?
When you define a function, it's always going to return none unless you put a return statement.
So
So
it's always the function will always return a function. So it means that function must return something to the user.
it returns something, or it always returns something to the user, whether it be none or whatever you have set it to return. So none is also a non-type object, as I've shown before. So in this case, say, where is that? So in this case, I just want to print a, and it's gonna be this one, and type F3. It's gonna be a non-type, right? So this is what it returns, but I have set in the just pass. Pass is when you want to run something, but you don't want to add anything, you use pass. And yeah, it will return an untype any which ways.
Okay, sir. And also, sir, if I define a global variable outside the function, can I use anywhere inside the function, even in the inner function?
Yeah, you can. If I use a global variable here, say t equals 6, and I want plus t. So that's going to give me the result appropriately. So 12 plus 6 is 18, right?
Yes, sir. Thank you, sir. Understood.
Yeah, no problem. And yeah, just for the use case of, uh, returning and printing, I want to add one more example, which is to calculate, the circumference and the area of circle. So in this case, it will be, I want to write the documentation first. So calculates the circumference and the area of the given circle. Right, so arguments is gonna take radius. So radius can be anything except a string. So it's just gonna be radius of the circle. So circumference equals 2 times np dot pi times the radius. So when I say np dot pi, yeah, np is not defined. So when you have errors like this, it's mainly because you are not imported the model. So if I import np numpy as np and then run np.py, it's going to give me the value of pi to a certain decimal place. So using that, I can find the circumference of that circle, and I can also find area of that circle. So that's going to be np dot pi times radius square, right? And I want that to print as circumference. So I'm just gonna put that in a formatted string, and I am going to round it up with 2 decimal places, and I'm gonna do circumference here. Area colon np dot round this up as well to how many decimal places? 2 decimal places, and I want to put area here, right? So we are getting an error. So this error is saying the brackets are not matching. So I think it's this one. I should have done this. Now it should not give any error. And when I say calculate circle with a radius of say 2. So circumference is 12.57, area is 12.57, and radius, when it's 5 units, it's going to be 2 pi times 5, and area is going to be 25 times pi. So that's going to give you 78. Is everyone clear with this one? I can also comment this out and return 2 values. So I'm going to return circumference, and I'm also going to return area. So in this case, this won't print out anything. It is going to give me a tuple. When you when you return more than one value using a comma, it's always going to interpret that as a tuple. And since I have not rounded it up now, it's going to give me values to say, I don't know how many decimal places there are, but it's going to give me a very big number there. So I want to round that up. How do I do that? So maybe I want to make another function, say round up x, return np dot round x. I want it to 2 decimal places, right? So this is a function inside a function, and I just want to do round up circumference and round up area. So it's gonna give me a floating integer of 32, and so it's rounded up essentially. And the way I want to do it is say 1, 0. So tuple, you can also extract each of the element with at the index. So the first element would be 0 index. So square brackets 0 is going to give you the first element, that is the circumference. If you're returning something, return, it's going to give us a tuple, circumference, and area. So it's always helpful to keep your docstring updated when you change the logic inside inside your function. So is everyone
Sir, I
clear
have a
with?
doubt.
Yeah, go on.
Can we use like both local and global variables in a loop? Like if we call a function I and uh, say we are adding the numbers, like we choose I in some range and adding another in global variable, something like that.
Oh, you mean change the global variable inside the function? So
No,
say
can
z
we use the
equals.
global and local?
We can, yeah. We can use global.
Yeah, and local variable, like for a loop, like it goes on loop. We
Yeah,
add
we can, I guess.
something and
I think what you're trying to say is iterate in a function using global variable and local variable.
yes.
Yeah, it can be done. Yeah.
So
I'm just
how
trying to
would we
find the
apply that?
use.
Okay.
I'm just trying to get a use case. Say for I in range Z. Is this what you mean?
Yeah.
And
Then
inside the loop, then say we have. I want to keep printing I, and yeah, I think if I call this function here itself, I want to keep printing till it's.
okay. Yeah.
Yeah. Does that
Thank
answer
you.
your question?
Yes.
Okay,
Thank you.
no problem. There's also one more, like functions can also be used to uh, like ease up your life. So I want to make a function where I want to plot. So plot of plot functions, right? So this function is going to take a function as an input parameter, and it's going to take limits. So upper limit, sorry, lower should go first. There's not really like why I did this. I don't know why, but it's just a way that lower should always come before upper. But anyway, this function is going to plot how this function looks like in a graph, given that x lower limit and x upper limit is given, right? So I'm going to write the doc string here. It says plots the function given upper and lower limit of x axis, right? So once this is done, as Pratik mentioned, we can use fig comma ax. That just stands for figure object and axis object. And I'm going to use the default parameters in plt.subplots. So it's just going to give me one figure. And I want to make, so sorry, the indentation should be there because all of this should be in the function. Make points for the x array. So how do I do that? So x array is np dot arrange. This is going to be lower limit and upper limit. Then I am going to make the points for y array. So y array is nothing but a list, say function. I'm going to call the function here. So this function is just what the function, like the input function. So I'm going to put x for x in x array. And then I'm going to do ax dot plot x array and y array. So this would be a simple use case of a function return figure comma x. Yeah, so this would be a simple use case of a function that can plot other functions to see how it looks like. So when I run this, I want to plot, I want to first define a function. So say s, define s. It's going to take a value of x and it's going to return x cube or maybe square. Let's just say square for simplicity, right? So now this plot function is going to take s, but we should not call s for now because it's already been called here inside the function. So s comma, what else? Lower limit, right? So lower limit equals -10 and upper limit equals 10. So it's going to give me a name error because PLT is not defined. I have to define PLT. So how do I define PLT? Import matplotlib.pyplot as PLT, right? So once I have defined all of that, it's going to give me a function. And this is what the function looks like. There's one more notation to define a function called lambda. So lambda x colon x square is essentially the same thing as this, right? So if I put this in brackets and I call this, say 3, it's going to give me 9. So lambda representation of, like, when you want to make a function, lambda is something where you don't want to spend time naming a function, or it's just something on the fly. It's like a handy way to define a temporary function without a name. So this is basically the same as S3, right? So this, whatever is inside the bracket, is the same as S. But I have not defined, like, I have defined else up here, but I have not defined this anywhere else. I have just, on the fly, I have done this. So when I want to, say, visualize a function, all I can do is say func equals lambda colon, sorry, x colon, say, x cube. So this will return the graph of f of x equals x cube. Are there any questions so far?
Yeah. Hello. I have a question. But then
Yeah.
this is regarding the previous problem. So let's say we have two functions. Okay, and there is one function which we start the execution with, and then we call another function within the main function. Okay,
Okay.
and after doing a particular operation, it will return a particular value.
Hmm.
Okay, now how do I use that value in my main function? Can I assign that particular value, whatever it is returning, as a variable value or a solution for something in the main function, and then go ahead with my next calculation?
Absolutely. So in this is what you mean, right? So comma AR equals this, and then is this what you mean?
Yes, but then will variables will be identified in the other function, because now they look like local variables.
They won't be defined, like, no, these variables will only stay inside the function.
But then if I want the now this value, whatever will be the solution of that roundup of circumference, that I want to use that number as a solution of something, and that was the reason I called a particular function. Now I have the solution, but now how do I use it in my the main function, which is
So
there, the main
define
problem?
new variables again. So Jigar, in the new cell, just write the same statement again. Cir comma ar equals to call the function.
Oh,
So
okay.
then you can use those variables outside the function.
Yeah, I think this is what you mean, right? So calculate circle, and then radius as 5.
So this way your function returns those two variables and then you call that function and assign those two variables. Now you can use it outside your function.
Yes, exactly. This is what I want. Yeah, thank you.
Okay. Any other questions regarding functions? Yes, Jatin, Siddharth, you can unmute yourself.
Sir, is there any ready-made function in the Python for calculating slope of graph? Because we usually use it a lot, slope of graph in physics.
Slope of graph. Slope of graph is nothing but like change in y with respect to change in x, no? So I believe as of now, I don't think there is an inbuilt function just to calculate the slope, but I believe you can make one yourself. Think of this as an exercise, like if you have a straight line, like draw 2 points, make a function where you have x1, x2, y1, y2, and it would return the slope.
Okay, sir.
Hello, sir. So my
Yeah.
question is that while using lambda, so we are using x as a single variable. What if I want to use two variables?
Okay, let me try. So lambda x comma y is x plus y, right? This is what you mean. And I want to see 4 comma 5. It's gonna give me 9. Yeah, works.
Okay, thank you.
Any other questions?
Hello.
Yeah.
Hello. So
Yeah.
I have a question regarding if we have a imaginary variable, let's say z, which is x plus iy. So if we want to like return that function, so that imaginary value, should we call that in a global variable or we can create that in a local variable?
Should we, like, what is the use case?
That
Like, what do you, I'm not
I
really, yeah.
suppose, so if we want to calculate the z value, which is just the basic function x plus iy. So in that, suppose if I just want to define what input user is giving, like suppose I just write 2x plus I 3i or anything, the basic function. So in that I which I'm using, do I have to predefine it in a global variable or I can directly create within a function as a local variable my imaginary value, which is under root minus 1?
As opposed to, I think imaginary numbers are handled by, Pratik, there's a library, right?
No, you
So
just start.
Python
You just
itself has
Yeah.
imaginary
Python will have
numbers.
basic Python
You,
will have.
you use j instead of I. So 3 plus
Okay.
2j is an imaginary number.
Okay, so I will be used for the index. Okay.
I can be any variable, but I is not used for imaginary. J is that this I have put in the basics notebook that I have uploaded yesterday.
Okay. Yeah. Thank you.
Yeah.
Yeah.
You can go for type.
Sorry, which one?
No, the type of 4 plus 2j, it should give complex.
Oh yeah.
Also,
Yeah.
sir, can you show if we'll take like z square or z cube, like the normal multiplication operation in the complex variable? So how we'll
Okay.
get the multiplication or the addition result? Any will do.
So z square is gonna give
Let's
you
take z square. Yeah.
and z cube. What else do you want to check? I think this equivalent to this one. Okay. Z conjugate function. So yeah, conjugate would be negative of the imaginary number. What else can we do with the imaginary number?
No, you may have, for example, two different Z1, Z2, and then addition, subtraction.
Yeah, we can try that, yeah. So 6 minus 4j. And then Z1 plus Z2. It's gonna give you this. Z1 minus Z2 is gonna give you this. Z1 times Z2 is gonna give you this. Okay. So what if I do round 1 to 88 1j? Okay. Okay. So yeah, I think Python has j as the imaginary variable predefined. You don't have to import any libraries or any other external modules for identifying complex numbers. So yeah.
Sir,
Yeah.
sir, why there isn't the squaring of J in cell number 97?
97. Oh, okay. So if I just square the imaginary number, it gives me 4.
That's a definition, no? The real square minus imaginary square plus 2 into this. And just a plus b square definition.
Yes, sir.
So should I proceed with curve fitting? Or is there any questions regarding functions or those things? I think Asma raised her hand.
Yes. So like we have a Dirac delta function, and we use in like various areas. So in that also we take the indices like I and j, or since the j is already predefined in this particular Python. So can we take any two variables, any like k, l, or anything, and can we plot a graph of that Dirac function at a particular value? Will get a peak. That can we try it out here?
Right.
Basically,
So
it is Kronecker delta function. I think he is asking
Yeah,
about Kronecker delta function.
Kronecker delta.
So it
okay.
peaks only when the two variables are equal.
Yes, sir.
Otherwise, it is 0.
Exactly. Yeah.
Okay.
So it can be defined that way. I mean, a function can be defined like you have said, no, that a equal to b, then it is true. Otherwise, it is false.
Then
So
then true value, how will it detect that true value will give you a peak and false value will give you nothing? Like,
See, graphically, the peak, you may have to define something. You say that what is the peak? Because typically in canonical delta, you will say that if they are equal, then it is equal to 1. Otherwise, it is 0.
yeah.
So you can define that in a function.
Okay. So that boolean also do we have to define that boolean, or directly it will print that whether
There
it
is a
is
Boolean
true or
variable
false?
type. There is a Boolean variable type in Python.
Yeah, so that's what I'm saying, sir. Like the boolean, it will do only the boolean operation or the mathematical too.
Only Boolean.
Like both simultaneous.
Jigar, you can actually show, define some A and B as Boolean variables.
I think, isn't it like from what I'm reading on Wikipedia, it's delta ij 1 if I equals to j and 0 if I not equal to j. Is that what you mean?
Yeah,
Correct.
yeah, yeah, yeah.
Yes.
That is the function.
Okay, let me see. So delta ij and let's skip the doctrine for now. Return or result equals 1 else 0. Is this what you mean? So zero. Wouldn't that sum up chronicle delta as like
Yes, it will sum up, but I think she was trying to look at whether it can be plotted as a three-dimensional function where at one point it is peaking.
okay.
Are you talking about visualization, something like that?
Yeah, yes, sir.
That is what I.
The 2D will
That is
also
what I.
work. Yeah, yeah.
Okay.
If you just want to plot, there is a SciPy signal module has unit impulse function. You can just, I, I can put the code in chat if you want.
So basically,
Try
if
this
you
out.
if you are plotting X and Y, and for canonical delta result, if you put different color, basically it is going to be a direct line with one different color. But you can show now this Boolean variable, Boolean operations. So that was another question which came.
Boolean operations.
Just simple like A is true and B is whatever false, and then A plus B, the Boolean operations, A and B, A or B.
Okay. So check. Let me create a function. It says check. Would you be able to give me some instance? I'm not able to kind of commit up on the spot.
No, I'm saying don't define a function, just write two variables. One you can call true,
Why do
another
we
you
need
can
even
call.
a variable? We can just say true or true, true or false, like that, right?
Give a variable just to give a feeling that you are dealing with variables. That's it.
So A or B, like that. Okay. So or
Whether A plus
is
B works. Check whether A plus B works.
that's B 1 and
So if we use plus or anything, it will use 0 or 1 instead of true or false.
So let
So
me
plus,
see if 2a plus b,
so
2, yeah.
plus is equal to or.
I think so, yeah.
Yes. So it counts, when you say plus, it counts true as 1, 0 as false as 0. So when I say 2 times true, that means it's 2 plus 0. So that's 2. No matter how many times I multiply false by, it's always going to give me 0.
So this
Because
is not a
false,
Boolean operation. Now this is not a Boolean operation.
and see this one.
Okay.
So A and B.
So
So
only
it
or
checks
and
if both
A
are correct.
and give you.
And I'm gonna comment this. Check if both are correct. A and B is gonna return false, right? And if it is A and A, it's gonna return true. Check if one is correct. So that time it is or. So A or B, true. Then is this
XOR operation.
what is this? So essentially and is just and here, and then or is just straight line. Yes.
And exclamation is not.
Exclamation is not, yeah. A not equal to B. Invalid syntax.
No, you'll have to say A not, then it will give opposite.
Oh yeah. A not B.
So
No,
we
no,
can't
there
do
is
A,
no B.
not B. Not is a unary operator.
Yeah, B is not
Makes
required.
sense, yeah. Not A.
Not A or not B. Something with that you can do. So not A should give
Yeah,
you false now. Yeah.
cool. Yeah. And this should give me true. Yeah. Okay, so that actually sums up Boolean operators in Python. I don't think there are any others.
Boolean operators can also be used to check conditions, right? Like two conditions, whether they are true at the same time.
Yeah, it is used in
Uh,
loops or
Ah,
functions, yeah.
yeah.
yeah. I think I can make an instance here where for I in range 10, so I is going to vary from 0 to 9. 10 is exclusive, so it goes through only till 9. I think Pratik mentioned this before, but if I equal to 6 break, right?
So this I equal to 6 is basically true. So if this becomes true, then it breaks.
Yeah. So this is your condition. You're checking if this I is equal to 6. Yeah, that sums up Boolean operations. So I think we can proceed with curve fitting if everyone is comfortable with it.
It's 4:30, but Jigar now. So
Okay.
can this be postponed to tomorrow's session?
Absolutely, yeah. Can be done.
Yeah. So
We'll
then
stop
we
here.
can stop this, and tomorrow morning 9 o'clock we will have next session with Krittika, and then the two sessions by Pratik and Jigar.
Okay, so let us thank Pratik and Jigar for the wonderful session, and we'll see them tomorrow. Thank you,
All right.
Pratik
Thanks,
and Jigar.
everyone.
Thank you all. Thank you, sir.
Thank you.
Thank you.